So yeah, we chose to use a QuickTime vulnerability for this. One, so, well, I'd like to point out that, so none of you are watching the demo live, which I'm very disappointed in, but someone did show up and they're from Linden, and they're just standing there.
Yeah, so it says, my name is Harry Linden, and there's like, it's like this little robot-looking guy. So
yeah,
you'll see him when the demo comes. Hopefully he doesn't try to do something to hurt our demo.
Yeah, we marked off the location. It's very, very secure. Okay, so we use QuickTime. One, because I like QuickTime vulnerabilities. The other is that this exploit was just very well behaved, and this vulnerability can best be described as, 1993 called and they want their bug back. It's a stack overflow in just in a header value, like in the RTSP response. Vanilla, and basically it's a straight stack overflow, very easy. But Apple's done some things. They've compiled QuickTime with stack canaries with stack protection called /GS and Microsoft Visual Studio. So what that does is, if you overwrite, close to the return address, basically the runtime will detect this and it'll just terminate the application. Give you a big pop-up that says a buffer overflow has been detected, so on, bad things, bad things. But if anyone knows about kind of exploiting /GS compiled binaries, you'll know that they didn't really fix the whole exception handler problem, because structured exception handling frames are also stored on the stack. And so what you can do is you can just overwrite that exception handler and then just run off the top of the stack or have something else crash in that thread. And then what happens is your exception handler is called before the one that handles that detects the overwritten return address. And so since you're getting your own exception handler filter called, you have control anyway. So basically that's kind of what we do. But Apple is also pretty good. There's a thing called SafeSCH, another compiler extension that Microsoft supports. What that does is that embeds the list of all exception handlers in a given module, like a DLL or an executable, into a list into that file. And so basically, if you're going to jump into an exception handler in that file, what the runtime does is it makes sure that it's one of those registered ones. And this is called SafeSCH. And the important point is to remember that it's DLL specific. So basically, if a DLL has been compiled with this, then you can't jump into arbitrary places in it. So, Apple compiled most of QuickTime with SafeSCH. And it's one of those things like horseshoes and hand grenades, close doesn't really count. So if they miss one module, that means you can get control. So that's what we do. So we just overriding the stack return address will trigger the warning. So we just go up the entire stack segment, so we just run off the top, triggers the exception, causes our overwritten SCH frame to get used, calling our exception filter, bouncing through, blah, 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 nothing but nets, so on. All right. Actually, I'll let you talk about this stuff.
All right. So at this point we have a QuickTime exploit, and we want to turn it into a Second Life exploit. And I should mention that there's nothing specific about this particular exploit in this process. So anytime you see a bug reported in QuickTime, you can always follow this to turn it into a Second Life bug. All right. So the first thing, and I had never really used Second Life before this, and so if you're like a Second Life pro, you'll laugh at this, but it took me like probably longer to figure out how to like make these objects and stuff than to actually do the exploit. So the first thing you do is you create an object, and there's the little GUI for creating it and stuff, and then you're like, well, how am I going to get people to see it? And so you either want to make it like really interesting, like there's an incredible amount of pornography in Second Life, so you make it like in the middle of a picture of people doing things to each other, and people will probably wander up to it. The other thing is, or make it very non-interesting, so they don't even see it. They just wander by, and they see it. For us, it's a pink box. Hey, look, he's got like a sign.
What's that? You want to go up there?
So this Harry Linden guy is holding a sign.
Hello, Shmukon. Nice.
Hey, cool.
We'll put him on the screen in a minute.
Yeah, here you do that while
I'm
talking.
Okay.
So there's even like more tricky things you can do, and I just found this out recently. You can actually take your object that is the exploit. So remember, the cool thing about these virtual worlds is objects are exploits here, right? So this little pink box is an exploit. And and it can be anything besides a box, but you can take it and you can actually put it underground, so you can't even see it, but you'll still get exploited by it. You walk by it, and the computer still thinks, oh look, there's an object with multimedia, and you get exploited, and you didn't even see anything, so it's crazy. Okay. The other thing is, if you want multimedia on these objects, which is what we want, you have to make it tell it to play. And you don't want the user to have to press play, which is sort of by default. But there's this scripting language in Linden, so you can make objects do things. And it's sort of like C, except it's entirely event-driven. And this is basically the script that we associate with our exploit. And all it says is, as soon as anyone touches it, make it play a video, and start a timer such that every second it starts the video. So basically, anytime you walk onto our land, within a second, so depending on when this timer happened to been initialized, within a second the movie will start, and then you'll get exploited. Okay, so we have an object, and then this is how you associate a URL with an object. So if you see this little, I don't know if you can see here. Right here, you can see it says RTSP : so that's the bad part. And then over on the right is the script. You embed that onto the object, and then the next person to walk along with, and and this was, there was a couple weeks when we did this when it really was a 0 day, and there was no patch. So basically, anyone who wandered by would get owned by it. But now this QuickTime bug's fixed, so I have a purposely old version of QuickTime on this machine for the exploit to work. But again, since the time when we did this, like 2 months ago, and now there's been, in that time in between, there's been a QuickTime bug that was a 0 day for like 2 weeks.
Yeah.
So it comes and it goes.
There's another RTSP, exactly.
Yeah. It was yeah.
All right. So we're going to talk a little bit more about the sort of exploit development for Second Life, and what about Second Life makes it such a wonderful development platform for many things virtual and exploits as well. Second Life is open source, which is one of the other things that we thought was really cool about it. So you can compile your own version. We'll see the source code to see how everything works. Like I compiled my own with debugging symbols, and so it's much easier to write an exploit when you have debugging symbols. It's just so much easier, especially when it's a complex application, and you have no idea why it's crashing or what's going on. You just look at the stack trace, look at the source code, you're done. It's easy. And so basically the process was, try things out, develop the exploit against the debugging build, and then once I have something that's solid, move it to the off-the-shelf downloadable version. And so one example why this is so easy, or this is so useful, is at one point it crashes. So after get code executing, it'll crash, giving an error saying, it's like an assertion failure. It's like, whoa, I don't know what's going on. I'm just stopping, and it says LL fast timer s cur depth is not equal 0. And then that makes no sense, and it goes into like a busy loop and crashes. And so if you have debug symbols, you just say, oh, okay, what's the address for that symbol? Oh, you're right, it's not 0. Let's make it 0, and then it's fine. So it makes getting what's called continuation of execution much easier. Also we used a lot of stuff from Metasploit because it has a lot of very good tools right off the shelf. Portable functions to write assembly code for you, shellcode encoders, and some really K-rad, sorry to go back to 1993, DLL injection payloads and stuff like that. And so the big thing that we wanted from this was continuation of execution. We want to take over our target's avatar, and basically it does us no good if the application crashes. And unfortunately, exploits are messy. I mean, especially the Stack Overflow. You're just overwriting memory willy-nilly. You're overwriting exception handlers. You're running at the top of the stack of the main thread, no less. And so basically, that's if your main thread is hosed, your application just dies. And so it's you have to kind of really do something application specific to keep the thing running.
Yeah, you would think. I mean, originally we thought that the thread that was handling all these QuickTime movies, it would be its own thread. We could just exit thread and we'd be done. Yeah. But it turns out it's the main thread is the one that's doing this. So as soon as you start doing things, the victim's computer basically, or their client freezes because you're in control of the only thread that is important, really. Yeah, exactly. So how the application is built is there's the main event handling loop, and basically just any object that needs updating just sets a flag. It goes onto a queue, and the main loop is just pulling